Lesson 5's homework, even more domain and range. We're going to spend some time talking about the appropriate domains that work for a particular word problem based upon what we're actually trying to accomplish with our domain and whether we can use decimals or have negatives and stuff like that. So for the first one, a local theater sells admission tickets for $9 on Thursday nights. At capacity, the theater holds 100 customers. The function m of n equals 9n represents the amount of money the theater takes in on Thursday nights, where n is the number of customers. What is the appropriate domain? So, n is the number of customers. We're talking about domain. Remember, whatever letter is inside of our parentheses is going to be our domain. So when we talk about the number of customers, we want to ask ourselves, can we have negative customers? I think we would all agree the answer is no. Can we have decimal customers? I think we would all agree the answer is no. So since you can't have any negative customers, you can't have any decimal customers, we are stuck with our whole numbers as our domain. They try to make multiples of 9, but that would be our range, not our domain. So remember, whatever shows up in the parentheses is going to be our domain. For the second one, let f be a function such that f of x equals 2x minus 4 is defined on the domain 2 less than or equal to x less than or equal to 6. The range of the function is, well, typically when they give us equations and a domain to plug in, what we want to do is we want to plug in the smallest part of the domain, and we want to plug in the biggest part of the domain. Now we can do this because f of x equals 2x minus 4 is a line. Some of our quadratics and parabolas and square roots might go in a slightly different way, but for our lines, we know that we can just plug in the smallest and the biggest, and we will end up with our answers. So when we plug in a 2, 2 times 2 is 4, minus 4 is 0, and for f of 6, 2 times 6 is 12, minus 4 is 8. So our range is going to be 0, less than or equal to 8, less than or equal to y, less than or equal to 8. Officials in a town use a function c to analyze traffic patterns. C of n represents the rate of traffic through an intersection where n is the number of observed vehicles in a specified time interval. What's the appropriate domain? And there it is. N is our domain. It's in the parentheses. And if it represents the number of vehicles, we should recognize you can't have a negative number of vehicles come in. You can't have a decimal number of vehicles come in. So therefore, we're going to have choice 4. You could have 0, you could have 1, you could have 2, 3, etc. No negatives, no decimals. 4. A toy rocket is launched from the ground straight upward. The height of the rocket above the ground in feet is given by the equation h of t equals negative 16t squared plus 64t, where t is the time in seconds. Determine the domain for this function in the given context. Explain. So domain, we're talking about our t, and t is the time in seconds. So if we think about time, we can't do anything in negatives. However, we can have decimal and fraction amounts of time. So unlike a lot of the other ones that have been positive integers or whole numbers, the best set that fits this is our non-negative real numbers, because we can have any positive amount of time. Okay, and I know sometimes people want to say non-negative rational numbers, but we can plug in, technically we could have pi amount of time, we could have square root of 2 amount of time. So realistically, we can have any of our non-negative real numbers because any positive amount of time would work for this problem.